Good afternoon. It's good to see so many people here who have checked out of their hotels looking for a nice, cool, dark place to catch some rest before they take their flight back to wherever it is they came from. Have you guys caught all the other WebObjects sessions this week? No. Catch some good sessions? Who caught Steve Heyman's presentation? Come on. Steve Heyman? And then we had James Dempsey's singing, right? Yeah. Okay. Well, are there any Canadians in the room? Yeah? Yeah? Well, I'm not Canadian. I'm from New Orleans, Louisiana, and I'm not going to sing or play the guitar or anything. We're going to talk about some really interesting stuff about WebObjects. Now, a guy came up to me yesterday and he said, Fitz, what is it that makes WebObjects, an application server, better than all the other application servers out there? And I said, how should I know, Bob? You're the product manager. Thank you for your jaded applause. Anyway, we're going to talk about making your WebObjects applications faster. We have a couple of goals. We're going to find and eliminate performance bottlenecks in your components, in your application, in your enterprise object model. We're going to talk about three areas. We're going to talk about the tools needed to identify trouble spots, including tools that ship with WebObjects. We're going to talk about certain types of bottlenecks to look for in your WebObjects application. And then we're going to talk about certain techniques which you can use from the get-go that will eliminate bottlenecks. We're going to talk about when to do performance tuning. Do you do it now? Do you do it later? Do you wait till you finish your app? Do you start from the beginning? We're going to talk about some tools that ship with WebObjects that make things a lot easier. Playback, WO events, WO stats, other methods to measuring performance of your app. We're going to discuss specifically WebObjects and EOF techniques to improve your performance. There's a lot of other techniques out there which we're not going to focus on related to programming and in general, but those are for definitely another session. And last, when it's time to upgrade your hardware. When it's time to get more RAM in that machine, when it's time to get more processors, when it's time to increase your processors. Fortunately, increase the number of machines you have for app servers. Fortunately, WebObjects makes it really easy to add machines to your server farm. Now, I'm a big fan of Donald Knuth. You know, I used to be a big LaTeX fan about 8 or 9 years ago. Anybody else here use LaTeX? You know, way back, you know, in the old days when XML wasn't even really the cool buzzword yet. Premature optimization is the root of all evil. Now, I put this in here specifically because that is one of the things that I am most guilty of. When I sit down, we get our design for application, we start coding, and I just want everything to be really pretty. We've got a nice clean slate. I want it to be fast. I want to make sure I don't do anything that is a performance bottleneck. Unfortunately, that's not the time nor the place for doing that kind of work. You want to work towards functional stability. You have a specification, you create your application. You want to get functionally stable before you start optimizing things, because you never know when you're going to add or remove functionality. You may optimize something that doesn't even wind up in your final application. You may optimize something that is buried in a myriad of other heavy-duty methods, and it turns out that it was just a waste of your time. You don't want to sacrifice good design and maintainability for optimizing. You don't want to wind up mushing everything into a single method that's 375,000 lines long just because it goes 10 milliseconds faster on your little performance meter. Speed is not everything. Optimization is about making your application faster, but making your development time just as fast. It's also about maintainability. Another thing I'll talk about is a big carpenter adage, which is measure twice, cut once. I usually cut my finger first, but you want to measure, modify, and then measure again. So create a controlled environment. This is really important. Create a controlled environment, do a measurement, make a change that you think might be an improvement, run your control test again with no other change in it, and then you can get conclusive evidence as to what helps and what hinders. Our technology framework provides a number of different very handy things to help you measure your performance. WO event profiles methods in your components. It's an extremely precise method for measuring what parts in your application take more time. There's also WO stats. WO stats is a very, very enlightening thing to have on your application. You could pull that up and tell at a quick look on one page what components are faster, what components are slower. You can see mean time. You can see the slowest access or the fastest access. It tells you a lot about what your components are doing. The playback manager can simulate multiple users. You set an NS user default in the command line, run your application with the recording enabled, and then when you quit the application, then you can play back this session with one user, simulate 10 users, simulate 200 users, hammering your application. Lastly, and one of my personal favorites is SQL debugging. We all know that EOF generates SQL to talk to your database. I'm really happy to say that I haven't put a line of SQL in an application since I started using WebObjects. And that was one of the things that really made my life hell before I discovered this technology. This shows you exactly all the SQL that WebObjects generates and sends to your database, as well as information about what WebObjects gets back. WebObjects gets back commit messages. It gets back, it says beginning internal transaction, finishing internal transaction. It'll tell you how many rows it gets back. It'll tell you when it's committed changes to your database. So before we get started measuring and testing, we need to come up with a test environment. So you want to have your test environment mirror your deployment environment. If your deployment environment is 2 Sun Enterprise 10000s with 64 processors and 4 terabytes of RAM, you don't want to make your test system an old G3 that you found in the back closet with about 32 megabytes of RAM running something completely different. You want to go for the same operating system. If you're deploying on Solaris, test on Solaris. If you're deploying on Mac OS X, test on Mac OS X. Don't switch and modify and change your environment in midstream. You want to attempt to mirror the number and kinds of servers. Now, this is something that is a little difficult to do, especially for really large-scale deployments. If you've got $500,000 worth of big iron you're running your deployment on, you obviously can't afford that for your test environment. However, what you want to do is try and mirror it as closely as possible. Try a particular scaled-down test environment of your deployment environment. And lastly, you want to isolate the test environment from your users. You don't want to have your test environment running in the same segment of your LAN as your production environment. You don't want them sharing the same database, for example. And I've seen that happen where a test environment used the same database as the production environment. You're not going to get, you have so many variables other than what you're testing, you're not going to get any conclusive results at all. Now, so we've got our test environment set up. We've gone out and bought more hardware. Now we're going to determine what pages are important. You have an application with 20, 30, 40, 100 pages. Make a list of the pages. What pages are going to be frequented every time someone comes into the app? For example, your main page, that's something you should work at to make blisteringly fast, because first impressions are paramount. When a user comes in and they see your application's front page takes half a minute to load, no matter how fast the rest of the app is, they're still going to be left with that initial thought like, God, I got here, it took me half an hour to get to the front page. Establish acceptance criteria. What you want to do is decide what is an acceptable speed for my application. If you decide that you want every page to return in half a second, well, then work to meet that goal. If you want every page to return in a minute, and your users will put up with that and not go elsewhere, well, then that's a goal to work for too. You might want to work on a big query page. So you have a query page that returns thousands of objects or raw rows, as we'll discuss later on. Maybe that should return in 5 seconds. There's certain cases where a longer wait is acceptable. Decide how many users you want to support concurrently. Is this application a small data entry app for a small company where you're going to have 20 or 30 people working on it a week? Or is it a large online store or an online presence where you're going to have hundreds of users hitting the app at the same time? Determine what you want to test for. Next, create test cases which exercise the important pages. Chris is going to give us a little demo of using WO playback and then checking with WO stats and WO events to see the speed of certain pages. So you might want to create specific isolated cases for certain pages that are critical to your app. Okay, now we're going to talk about preparing your test cases. Enabling recording for your application. The WO recording path. So if you have your application, you've finished your feature complete, you're ready to do a little bit of optimization. You set the command line argument, WO recording path, you set it to a directory. In our case, we use temp/foo.rec. This is a directory where the WebObjects application will write out a series of transactions, requests and response, which records you're visiting the app. Manually execute a test case. Set up that variable, set up that NS user default in your application, launch the application, execute the test case, stop the application. Now you can repeat this with different directories for each test case. You can point the WoW recording pad at different directories and say, this test case is going to test the big fetch page. This is going to test the main page. This is going to test a simulated user walking through the application, finding something, and then going back to another part to purchase something, for example. Now, when you run your test cases, so now that we've enabled that user default, we're going to pull that off of the command line, and we're going to run the app like we would run it in deployment. Now, there's certain defaults that you're going to want to enable or disable when you deploy your application. First is WoW caching enabled. WoW caching enabled allows, which defaults to no, is what allows you to do rapid development on your application. It allows you to make changes to your .wad and your .html files, save them, and reload that in your browser and see it immediately. By setting this to yes, WebObjects knows that it's safe to cache these templates in memory. So you'll get a small hit the first time WebObjects reads the templates off the disk, but it will cache them. Next time, it will just follow a pointer, a reference, in memory to retrieve that information. WoW debugging enabled. You want to set that to no, most especially if you use WoW application.debugString. That's a great method to use. You can put tons of debugging print statements in your application, which you'll see in your console. And then when you deploy, kick this over to no, and go your merry way. You won't see any of those. You'll still see log strings. You'll still see printlns and whatnot, but it'll turn those off for you. Last but not least, and it's something that I want to say with a little bit of a caveat, is WoW allows current request handling. That defaults to no. Now, what this enables, if you turn this on, is multi-threading in your application. This can provide a dramatic speed up, but I strongly encourage you to be familiar with the caveats of multi-threaded programming before you turn this on. In my experience, multi-threading bugs are extremely difficult to track down, and believe me, it's something that you don't wind up working with if you're not familiar with multi-threaded programming. So now that we've got all that set up, we're going to disable the recording, start more than one instance if you're looking at a large deployment, start one instance if you're looking at a small deployment, whatever your test environment is. Run the playback, run one playback concurrently, two, run one at a time, run them serially. Let the system achieve steady state. Now this is very important. You have to remember that your application contains methods that start and stop. A new session is created and it lives for a certain period of time and dies. The session death and birth are something that's very important to your application because your application is going to run all day, 24/7. So what you want to do is let it reach a point where sessions are expiring and new sessions are being created. So it'll create receive a sort of a steady state. So we've run our application, we've done our playback, we've done our playback. Now we're going to take a look and see what kind of information we can find out about this application. First, we're going to look at a couple of pages. We have WoW stats and WoW events set up. Now, these are direct actions. They are, out of the box now, disabled. You need to set a password for them to use them at all, which we've done in our sample app. And the WoW stats is something you can just go to at any point after you've hit the app. And it's going to give you this aggregate data it's collected about your application on a component level. Now, a component, as we know, can be as big as a page, as small as a character. So it'll give you information on all of those. You might want to pay attention to the page ones. You might want to pay attention to a certain subcomponent that's taken a lot of time. Configure event recording. Now, event recording is something you need to go in and turn on. There's several different buttons you can set to say, these are the kind of events I want you to gather information about. WebObjects can amass an incredible amount of events in a second. I don't even remember what the number is. Maybe in Q&A one of the guys from engineering can say, but it's blisteringly fast and has very little effect on your application. So you go to WoW Events Setup, say, tell me what these events are, do your playback, and then you can come back and look at the WoW Event display page to see sub-transaction times all the way down to the method granular level. Now, for those of you who have been around doing WebObjects work since the old days when we used that other language, there were tools available for you called gprof, gmon. You'd have to build your app in profile mode. You'd have to run your application. You'd have to quit your application. You have to run it through another program, and you get this really nice information that told you about this. Well, that's really great, but that's something that you had to prepare for. You had to sit out. It was very time-consuming. This is something that happens on the fly, in the product, out of the box. So we've done that. Now we can use WoStats to find the pages that don't meet our acceptance criteria. Maybe we found a page that takes 10 seconds. Well, let's look into why. What's taking so long on that page? Is it a method that's very expensive? Is it a fetch to the database? Is it a multiple fetch to the database? Well, event display, after you find out what pages are giving you trouble, can tell you what methods in that page are giving you trouble. Who's taking the most time in your application? You can evaluate, and you should evaluate the times relative to the total time that your application is running. Pay attention to what is used the most. If you have a page that's hit once a day in the corner and it's really expensive and it takes 20 minutes, you might not want to dedicate resources to fixing that page. You may instead want to dedicate resources to making the front page faster or the query that everyone does. Now I'm going to ask Chris Miner, Senior Consulting Engineer with Apple iServices, to come up and give us a demo about using WoW recording and playback. Chris?
So we need the guest one. Thanks. So we're going to skip the recording portion because we did that earlier. But just to show you what that looks like as a result, use the WoW recording path. And we created this as a result of going through our application in a typical usage fashion. We ended up with this recording. And inside here are a number of files. You can see the request and responses making up transactions. So this only has 9 transactions in it. And then we'll just look at what one of the contents of one of these. And you may be able to tell from that it's a typical HTTP request. It's just recording the request that came in from the browser that the app got. And then afterwards, it records the response it sends out. So that should look a lot like an HTML page. So then I've already got this application running. Actually, it's this one here, sorry. And then from a command line, I'm just going to start up our playback, where it's going to read from that directory, send each of the requests to the application, and then compare the result with what it gets back this time. So we can see up here that it's going along doing some logging to show you that it's actually hitting the app. In this case, we only have one playback going, and we have only one application instance. And down here, you can see some of the results, some of the information that's coming back for us. So you can see that it's got perhaps the requests. It'll go 0 through 8, and then it starts over. So the next one would be a new session. So each time it gets to the initial request again, that's going to the main page again, and that's starting a new session. And then you can see the transaction times. Let's stop that for a second. Over here, this is the comparison of the bytes that it expected to get versus the bytes that it actually did get. So that can, in some respects, you can tell if there's a real problem with your app, maybe a defect of sorts. If it's returning back something wildly different, that might well be an error page, something dramatically different than what it expected. So let me start that running again and go have a look at the WoStats information. So I got the login page as mentioned before. By default, this will come up. If you haven't set up your app to allow you to log in here, you can't. There isn't a command line option for that. It's kind of a security feature. And there's a lot of information in this page. We're only interested today in part of it. So I'll just go down to that bit. This happens to be, you can see here, there's two major sections, the component action statistics and the direct actions. As you can see, there are no component actions, and that's because this app relies exclusively on direct actions. We see here on the left the page names. It doesn't give you anything that's at a subpage level in this view. And then I'd like to point out these minimum and maximum times over here. You can see that it's not terribly obvious on this hardware because it's ripping fast, but on my laptop it showed a dramatically different value for the max and for the min. I mean, this one's still pretty large. But it just goes to show that maybe on the first time you hit the main direct action, the default direct action, it might take a lot longer for something to happen. But then over time, this average is going to go lower and lower. And you can see there the 0.01 versus the half a second. So what else? So another thing we should be able to see in here are what we just saw there is that our session timeout's very short. I think we set it to about 15 seconds just to demonstrate this other feature, which is the current active sessions versus the maximum. So here we have 163 sessions created, but our current active sessions is only 68. It's likely to stay at 68 for a long time. It might fluctuate, go up or down one, but it shows this app's essentially being driven at a steady state, which is essentially what we want, because otherwise information we'd get about CPU usage and information we get about RAM usage would be pretty much irrelevant. So now go on to the WoW event display. So here's the event logging that Fitz referred to. We're just going to look at component events. And then once you set up what events you're interested in, you can actually display those events. In this case, we're going to just reset this. To get a fresh view. So our playback is still running, so this information is still getting updated. And you can see that for the component events, there's the pages, but it's also the sub-page components as well. There's different sorting capabilities to show these events in different ways. So we'll group them by page. And then we can see something like, perhaps that the add movie page takes what seems like an awful long time for the number of calls relative to anything else. So if you were going to get some sort of speed increase, you might look for something in here on an app-wide basis. Something else that's worth noting is that if these times per call are below what your criteria is, then you're pretty much done. So this just tells you don't have any performance tuning to do, which is pretty much the case in this application. But you can drill down in here and see where the cost of rendering a component comes from. So at the bottom of things, we see the WD footer costs pretty much nothing. So maybe I'd turn my attention to the WD table element if I were going to look for a place to pick up some speed. Okay, and that's it. Fitz?
Okay. All right. Thank you. Now we're going to, and now we've talked about ways of measuring your performance of your application, we're going to talk about techniques for improving the speed of your application, techniques specific to WebObjects and the Enterprise Object Framework. Now, maybe we could review this week. We talked about there were 2 Enterprise Object adapters available. There were the JDBC adapter and the, anyone else remember? The none adapter. Now, the none adapter is extremely fast. There are absolutely 0 round trips to the database, and however, it's not quite as useful as the JDBC adapter. We want to reduce trips to the database. EOF writes, like as I said before, this SQL and sends it to the database, and the database sends back, well, data. Sometimes EOF will ask the database for data in a not so intelligent manner, we might say. It might repeatedly ask the database for little bits of data that it could have just asked for all at once. So to find out where these problems exist, we turn on the user default EO adapter debug enabled. Now, for those of you who use print statements in your application to see what some value of something is, where some sort of value changes, or where you are currently in the request response loop, you'll see a number of print statements go by in your console. When you turn on EO adapter debug enabled, you are going to see more stuff in your console than you ever knew what to do with. You're going to see when EOF first logs into your database. You're going to see every round trip thereafter. Tons and tons and tons of fun things to look through. Now, when you look at this information that EOF tells you, perhaps you'll see that there's multiple round trips for your database for one request response loop. Maybe you're fetching, for our example, those of you who are familiar with the movies database, I'm not creative enough to come up with like election results and stuff like that. So I grab the movie database. It ships. It's in the Java Business Logic examples. It's tried and it's true. When I fetch movies, and then perhaps I navigate some of these faults one at a time, as each fault fires, it might make a separate trip to the database. And it's extremely inefficient because we all know that each round trip to the database is pretty expensive. So we're going to talk about ways that you can optimize that. One is to use batch faulting. Tell EOF that when you fire off one fault, go get a whole bunch more. We can use prefetching. Tell EOF, when you fetch these entities, I want you to fetch these relationships at the same time, just because we're going to be using them pretty soon. We could use a shared editing context. This was a recent addition to WebObjects last year. Fantastic. People were already doing this, putting an editing context in their application and talking to it. This is a really intelligent editing context that has relations to each editing context in the session. You could put reference data into the shared editing context, fetch it when your application starts up, and never fetch it again. Or, well, there's a little detail in that I won't go into right now, but it will refresh your data eventually. So if you have a WO pop-up containing all the cities that your company may service, or a WO pop-up containing something like all the products in your product line, it's something that doesn't change or changes very infrequently, might be a great candidate for shared editing context. Make your app read-only. This is extremely fast. If you have an application, a scenario, for example, where you have a back office application where users enter data, where they change data, where they delete data, and then a front application for your users where they just come and look at things. It's sort of a reference application. You can actually go ahead and put everything in the shared editing context. And your application will rarely have to go back to the database for anything. Not only is it extremely fast, but it's extremely memory efficient because you don't have all these duplicate copies. Remember, each editing context that contains an object has another copy of that object. For very good reason, mind you, but when there's situations where you can avoid that, you certainly would want to. Last, you want to avoid recurring fetches of reference data. Certainly, the shared editing context takes care of that for us. Another thing we can do is reduce the amount of data that we get from the database. You can use raw rows for non-object data and very large fetches. Raw rows are, as we'll see, they're a big speed improvement on just a standard fetch because they fetch the information into EOF just as always. The information is fetched from the database, columns and rows, put into a dictionary, but instead of taking the next step and creating your enterprise objects with the business logic built into them, you just get this raw data, just straight attributes. There's occasions where it's very convenient to have that. Use fetch limits or don't allow unrestricted searches. Now, I have to say right now that my favorite search engine out there is Google. You go to that, I find obscure error messages. I type the error message into Google, and it comes back with a page with the answer on it. I mean, anybody else that does this? Anyone else? No? Cough or something. Is anybody still awake out there? My goodness, you shouldn't have eaten that those big lunches. It only gives you, you can search for the word Apple, and you'll get hundreds of thousands of responses. It'll say, found 4 bajillion pages, and it's only going to show you 200. That encourages you, as a user, to refine your search. Maybe you want to look for Apple Computer G4, Apple Computer G4 with a cinema display. Maybe I'll optimize your programming experience. Don't allow unrestricted searches. Make the user enter some sort of criterion. Now, this isn't always necessary. If you have a company with 50 employees and they have search on last name, search on first name, sure, let them hit return, let them get all 50 employees and surf around to their heart's content. If you work for a big company that has 200,000 employees, this might not work so well. An unrestricted search might allow them to fetch your whole database, at which point your DBA is going to come hunt you down and kill you. And then you're also going to run out of memory in your machine. So now, I'm going to go ahead and give you a little demo of some of the things that we did here. So let's see. We should have 2 different screens coming up shortly. Now, those of you who have been to the WebObjects sessions this week, you guys have probably seen some really cool demos, some really cool graphics. You saw XM Elementary. We got movie mechanics. I have to confess, when I finished writing this demo yesterday at about 11:30, it looked like, W3C consortium around like 1994, the gray background with the big HRs across. We handed all this stuff over to Matt Furlick. A lot of you know Matt Furlick, who really made this stuff look great. Let's hear it for Matt. So what I have here is an application called Movie Mechanics, which I've already cranked up and done some fun stuff with. So I'm going to stop it for starters. And yeah, I didn't even mean that. And now we're going to start the application again. And when it decides to start up here, there it goes. We have a couple of different defaults that I've set up in here. In fact, I could probably still go ahead and take a look at this thing here. Let's see, optimization. Did I click that right? Optimization, targets. Yeah. Targets. Anyone? Resize? Oh, it's way down here hiding, right? There we go. Yeah. Okay, you'll see I have UAdapter debug enabled to yes. I've got it set to WoW port 1729 because I'm hitting it from this machine over here. And then WoW auto open in browser. No, I'm not a big fan of the auto open in browser thing. So let's go back to where we were. So the application is launched here. And you'll see it says welcome application. It gives you this URL and some other information. And the first thing it tells you here is connecting with dictionary. Okay? It's connected to our database. It began an internal transaction, fetched 5 rows. Okay? Now, the first example we're going to do here is our shared editing context. See, it showed me. Shared editing context example. Okay? We're going to take a shared editing context, using objects from shared editing context versus using objects that we're just going to straight fetch from the database. So as you see, we have those 5 objects. So when I click on this, all right, you notice up here, no change. No change, didn't touch the database, didn't do anything funny. So let's find out how long that took. That took 0.03 seconds. Now, tell you a little bit about how this timer's working. Okay, I've written just some simple Java timestamp methods. In the awake of my page component, I put on, I'm out of the light, I better come back over here. I put on the page component. In the awake method, I do a timestamp. I get the current time and I save that. And then at the very end of my append response, I have another component that merely takes the current time at that point and then gets the delta between that and the start time and then squirrels it away for me to put in this little clock here. So now what we're going to do is go ahead and do a regular fetch. You'll notice, touch the database, 5 rows were processed. Let's find out how long that took. Yeah, don't make a lie about it. I mean, this is actually happening. They didn't just hard code these values. So this really fast machine, unlike my laptop. In fact, if I look out there, I do see a couple of titanium laptops. Yeah, I'd like one of those. Let's talk about what these do. The shared editing context fetches the data at the beginning of your application when your application starts. No round trip to the database. It's way fast, and it's great for reference data. The regular fetch is just a plain old fetch, and it requires at the least a round trip to the database. And as you can see, it's a lot faster. Shared editing context, again, this is basically following a reference, and the regular fetch talks to the database. So now we'll move on to something a little more interesting, batch fetching and pre-faulting. So let me see, can I see a clap or make a noise? Who's used the batch fetching and pre-faulting here? Batch faulting and pre-fetching. Okay, so we're going to have some people who already know the answer to this, right? So we have 3 ways of getting this data. We do a regular fetch. Now, the way this component works is I'm fetching all movies out of the movies database, all 88 of them, and then I'm iterating through the movies, and I'm touching the roles relationship. Each movie has a role. Indiana Jones, for example, has Harrison Ford, has the role of Indiana Jones and the role of Marion and whatnot. I'm triggering that fault for each movie. So iterating, triggering those faults. Now, we have a regular fetch, which it just goes through, does the fetch, and then triggers those faults. We have batch faulting on, which sets the batch faulting on the roles relationship to 25. So what that tells EOF is that when you fetch these bunch of movies, and you navigate to this particular relationship, go ahead and get some extra stuff while you're there. You know, you're running to the grocery to pick up milk, pick up some butter, you know, was it a stick of butter, a loaf of milk, loaf of bread, and a gallon of milk. Pick up some other stuff while you're there because it's likely we're going to need this. And last but not least, prefetching, which is a very particular thing, which says when we fetch the movies, I want you to prefetch these certain attributes of the movies while you're there. Okay, so we have these 3 things: regular fetch, batch faulting, prefetching. Who thinks the regular fetch is going to be fastest? Anyone? Thanks, Mark. Who thinks batch faulting is going to be the fastest? Come on, it's a little race here. Anyone think batch faulting? You all know that prefetching is at the bottom, so it's the fastest, right? All right, who thinks prefetch is going to be the fastest? All right, all right. Okay, so let's see what's going to happen here. Regular fetch. Look at that. Oh my God, would you look at that? Every one of those big lines that begin, from begin internal transaction to commit internal transaction, is a round trip to the database. Now, man, I can't even, that was a lot of round trips to the database. Look at that. 88 to be precise. Let's find out how long that took. That took 7.04 seconds. Now, mind you, on my laptop, this takes like 20 seconds. Batch faulting, look at that. Now, we saw a good number of transactions go by here, but they're a little different looking. Right there. You see here, this is some information I put in here. Whoa, whoa, it's still going. What's it doing now? Hello? Someone telling it in this machine? Anyway, let's try that. Let's see what that comes out to. Okay. So anyway, here we have this transaction here that fetches, in this case, 84 rows. It fetches, it has a big OR select statement. Select the role where the movie ID is this, or this, or this, or this. So it comes back with a whole bunch more of these relationships on the first shot. Prefetching, boom, right back at you. How many fetches was that? 2. Now look at the difference from that. A regular fetch where you're faulting, you're doing multiple round trips to the database, many, many, many round trips to the database. 7 seconds here, 2.23 seconds for batch faulting, and 0.52 seconds for prefetching. Now, here's something that's interesting about this. Some people out there might be saying, well, geez, of course the first one's slowest because then you fetched it all in. And in sleep, in this component, I'm invalidating all objects in my editing context, which pretty much wipes everything clean and makes the EOF do everything all over again. So we'll try this again just to show you that there's nothing funny going on here. It's actually going to the database again each time. It's going to be a little faster because certain things are cached and happy and whatnot. So batch fetching, 2.40 seconds this time, and last but not least, the prefetching, 39 seconds, 0.39 seconds. Let's talk a little more about them. Regular fetch, 1 round trip to the database for each fault fired. Can be extremely inefficient, very, very time consuming. Batch faulting, it's defined in the relationship in question. Now this is the difference between batch faulting and prefetching. Batch faulting, you can define that programmatically or in EO modeler per relationship. You define it once in EO modeler and your applications use your model and they just go their merry way and it just happens. To many relationships only, you can't do batch faulting on a to-one relationship. This fetches, again, the next n objects whenever a fault is fired. So for example, in this demo, we set batch faulting across the roles relationship to 25. So it fetches 1, it faults in 1 relationship, and it gets the next 25. Last is prefetching. It's used on a fetch specification, so you have to consciously go in when you create a new fetch and say, I want you to prefetch these things. When you get the movie, I want you to prefetch the director, and I want you to prefetch the roles. And you can prefetch multiple relationships. It adds only one round trip to your original fetch, and it's very, very, very fast. So enough of that. We'll move on to probably another one of my favorites, raw rows. Now, raw rows and objects. I just kind of blew it. I hit the button already. So what I'm selecting here are all the movie roles in the database. I wanted something with more data. Obviously, I don't have that much data in this database. The difference is seemingly small when you have a small amount of data, but when you have a lot of data, the difference is really, really big. So I just fetched the raw rows inadvertently, and let's take a look and see what the time was on that, 0.08 seconds. Now I'm going to fetch objects. Now raw rows fetches rows out of the database, every column in the row. And in this case, I'm fetching every column in the row. You can write SQL and only fetch certain columns if you wish. You can fetch the primary key and maybe the title of something. But in this case, I fetched everything. Stored it and gave me back a bunch of dictionaries. Objects, I fetch the information from the database. You get all attributes for each object, and they're wrapped in enterprise objects, and boom, you have your enterprise objects. So let's see how fast that goes. 0.13 seconds. Now we'll click it a couple times here to sort of let things normalize out and see what the difference is. The difference, it depends. You'll see different speeds, but on the most part, it tends to come up to about 50% or so of speed improvement. Depending, if you tweak out your raw row fetch, you can see a really, really huge improvement. Now, there is a fantastic article that I use for reference on this, on Stepwise, written by Malcolm Crawford, and I think he's sitting right there, that tells you in great, great detail. Thank you, Malcolm. Yeah, there you go. There you go. Malcolm, as we all know, has done us a number of good services this week. Let's talk a little more. Let's talk a little more about what these do. Raw rows. Raw rows don't instantiate enterprise objects. You just get back dictionaries. Key value. Title, Indiana Jones. Director, George Lucas. It was Lucas, wasn't it? Music, John Williams. Okay. It's very fast. Doesn't have to select all columns. Objects is just a plain old fetch. It creates objects for all the EOs it fetches, and it can be slow for very large fetches, especially when you're dealing with tens of thousands of objects. So I'm not going to take a look at WoW event setup right now, but I will really quickly see if I can hit on WoW stats and see what it tells me about this application of mine that I was running. Okay. So here we are. We have Be Nice and Share, which is my little shared editing context demo, with an average time. That's basically pretty fast because even the non-shared part is only fetching a little bit of data. There's the venerable main. Round trips. Round trips is where we did the different kinds of fetching, batch faulting, and prefetching. You look at that, the max is 7.2. You see that was the round trip where we went and batched and we single faulted everything in. And last but not least, raw rows, which was basically pretty fast because again, we're just fetching the object. A single fetch, as you can see, we fetched 450 roles. Still, that was very fast. I just kicked something over here. And still, it was very fast because we just did one round trip to the database. So that's about it. Let's get back to the slides now. Thank you. Okay. I had to get a Star Trek joke in, but I'm not a big Star Trek Voyager fan, so I went with the classic, right? Lazy instantiation. I took a Programming WebObjects 2 class at Apple. In fact, I took Programming WebObjects 1. But Programming WebObjects 2 was taught by Kai Christensen. It was an absolutely fantastic teacher. Anyone had Kai for a teacher? Oh, it was the greatest class. I didn't fall asleep once. Kai said something to me that just absolutely killed me. He said, when you're programming, he says, you want to cook your steak until it's smoking, and then 10 seconds less. And I said, Kai, what the hell does that mean? He said, you want to wait till the absolute last second to do something. If you don't have to do it, don't do it because it may turn out 20 feet away from here, and you don't have to do it. Use lazy instantiation. This is an example here We have Shatner's ego, which is going to take a long time to get because it's really big, as we all know. So the first time it's called, it checks this private instance variable to say, is this null? If it's null, it goes ahead, fetches it, squirrels it away in the instance variable for the next time someone comes through, and then returns it. Huge bonus. It's a great little trick to use. Back to EOF stuff, subclass EOGeneric record instead of EOCustomObject. EOGeneric record has a couple of little tweaks to the key, with the key value coding, the way it stores the information for the attributes of your EO. It's blisteringly fast, especially in WebObjects 5. It's absolutely incredible what they've done with this. Don't overwrite. Now, another thing that EOGeneric record does as well is, by default, deferred fault. Is it deferred faulting or shared faulting? Deferred faulting. Deferred faulting is enabled. Now, whenever let's say we fetch a movie, okay, and it has several attributes. It has role. It has a link to director. What we used to do in the old days, back in the 1990s, we used to create a fault for each one of these attributes. Now, if a movie, let's say it has 10 possible faults. We fetch 1,000 movies, okay? So we've just had to create 1,000 movie objects plus 10,000 fault objects. Now, the EOGeneric record by default creates one shared fault for all these different faults. That's an incredible speed up because we don't have to create all these additional objects, even though the fault objects were small. Next, and this one seemed a little bit obvious, but I've seen some people do some weird stuff. Don't override value for key. Key value coding, one of my greatest friends in the WebObjects framework, is patented key value coding, as we all know, and we know that software patents are evil as well. Don't override that. Value for key and take value for key are called incredibly often in enterprise objects, in your WO components, and they're optimized to be as fast as possible. Something you don't want to override. Certainly if you're debugging, you want to put something in there, print statement, but make sure you rip that whole thing out when you're done. WebObject specific stuff, we can synchronize bindings by hand. We have synchronizes variables with bindings, which is still nowhere near as long as add objects to both sides of relationship with key. We have synchronizes variables with bindings, which in WO component by default returns true. Now, this was one of the things that really blew my mind when someone explained it to me. They said, when you synchronize, when you go through the request response loop, if you put a simple string in your page, it's going to print out the title of a movie. Or something, or you have your own subcomponent. Let's say it's a custom subcomponent that takes in a name or something. We all know the request response loop. Big fans of the request response loop. Awake, take values from request, invoke action, append a response, and sleep. Okay? Those three middle ones, take values from request, invoke action, append a response. There's a lot of stuff going on there, and one of the things that goes on in those three methods are variable synchronization from parent component to child component. What that means is that take values gets called, boom, synchronize. Pass the value into the child component, pull it back out. Do it again, invoke action, pass it in, pull it out. Do it again, append response, pass it in, pull it out. That's like 6 method calls there. If you have a subcomponent that you're using everywhere, say a button bar component that just has some buttons on it that you want to pull some information down from the parent for. Say it's just a footer, and we'll talk about a way of even making that footer faster in a moment. And you just need a little bit of information from the page. You might want to say, look, WebObjects don't synchronize these variables for me, but instead I'm going to take care of it myself. And then in the appropriate method of the 3 above that I mentioned, you can pull or push up that value that you need. Now, if you want to talk even faster, we could talk about using stateless components. Now, a stateless component, whenever a component's instantiated, you get a new component. You say, page with name, boom, new component. You put a component into a page. When that page gets instantiated, that subcomponent, boom, gets instantiated. If you say that a component's stateless, WebObjects knows that this is a component that's not going to change based on a session or based on something a user's done. It's a stateless component. It loads it up once and it reuses it over and over and over again. So if you have 700 users on your website and you have that little footer that has the big legal disclaimer in it, make that stateless and you don't have 700 of those lying around. You have one. Not only is it faster, but you use less memory. Now, in the end here, we've sort of thrown a couple little miscellaneous things, some of which aren't necessarily related to WebObjects, but session timeout. Chris showed you before we had our session timeout set to 15 seconds. That's pretty extreme, but you might want to see what the typical user experience is in your application. When a session times out, that memory is available to the garbage collector to be picked up eventually. So that means that when your session gets bigger, it can squish it back down a little more. Fetch outside the request response loop. If a user logs in, then you need to get some data based on that user, but you don't need it right away in that first page. You might want to do a delayed action to fetch that, or to put it in sleep, or somewhere outside, somewhere safe to put it outside that the user's not going to be waiting. Index your database. I'm a big fan of getting someone else to do this for me. You can notice a marked improvement, especially if you're just using single attribute primary keys, which is what we all know and love with the Enterprise Objects Framework. Offload images and static data to another server. If you've got an application that's serving up, I just experienced this recently, QuickTime VRs, 300, 400 kilobyte VRs, and you got 200,000 of these things. Well, you don't want your same web server as your app, that's serving up your web app to be serving up these images. You might want to have an additional web server, vrs.yourcompany.com, images.yourcompany.com. Have that serve up the static images and VRs and sound files and God knows what. Check your HTML. Check the HTML. This is, wow, this is like really obvious to me now, but wasn't obvious to me at the time. I had a page that we designed for this client of ours with all these nested tables, and it looked just the way they want it, and I was like, oh, thank God that's over with. And then we hit the page, and it just took forever to render. It took forever. This was back in years ago, 1999, I think. Check the HTML. See if you can't optimize your HTML. See if it's actually compliant. Run HTML. Run a linting program over it. Make sure it's valid HTML. Remove extraneous tables. Do as much as you can with as little as you can. And last but not least, there's Java. There's Java performance tuning things like Optimize It or JProbe. I believe Optimize It is currently available on macOS 10. Now lastly, but not leastly, we'll talk a little bit about what we've learned. We talked about determining where the bottlenecks lie, measure, modify, measure. Remember, again, in a controlled environment, change only one thing. We talked about WebObjects and EOF techniques. We have batch faulting, prefetching. We have synchronizing bindings, not synchronizing bindings, stateless components, that sort of thing. General programming techniques, lazy instantiation. Upgrade your hardware. Huge thing right here. If you're running your application and you're hitting swap in a deployment environment, you're doomed. There's nothing that you can sit down and optimize and improve that the second that your machines run out of RAM. And oftentimes you'll discover that hardware is a lot cheaper than developer manpower. So with that, I want to let you know that if you hurry up, please don't run. The WebObjects lab is open for another 20 minutes downstairs in room K. The only session left for WebObjects track is the feedback forum, which is going to start at 3:30. And there's your contact information, which I'm sure is all new to you.